Exponential functions, the overview. This video is going to be short, quick, going to tell you the most important information that you need to know to be successful in the topic of exponential functions. The first thing you need to know is that any pattern that is multiplying or dividing is considered exponential. If there's a pattern of multiplying, what that means is you'll start with a number and then maybe you go times 2, times 2, times 2, times 2 every single time. And if the pattern is multiplying, this is considered a growth exponential function. Now, if the pattern is dividing, such as divided by 3, divided by 4, that is called a decay function. The second thing you need to know about exponential functions is that they all have the same equation format. And this format is y equals a times b to the x. The a is our starting value, or our y-intercept. So whatever number is in the front of the equation is your y-intercept. The b, whatever number is at the back of your equation, is considered what we call our common ratio. And the common ratio is what is the pattern of multiplying or dividing. So if the pattern was times 2 times 2 times 2, your common ratio value would be 2. Likewise, if the pattern was divide by 3, divide by 3, divide by 3, your common ratio would be 1/3. Now, to determine if an equation is a growth or a decay, you look at this common ratio value. For it to be a growth, your common ratio needs to be greater than 1. So it could be 1.1, it could be 2, it could be 9. Anything bigger than 1 makes a growth. So a decay function is anything where your common ratio is smaller than 1. So it could be a decimal point or it could be a fraction, just as long as it is smaller than 1. The third thing you need to know about exponential functions is that when an exponential function is graphed, it makes a curve. And there are two types of curves that it's going to make. We have growth curves, and a growth is whenever your common ratio, or your b value, is greater than 1. So it starts low, it grows tall. Notice how my growth curve did not go underneath the x-axis. It will never go underneath the x-axis. Now, a decay curve looks a little bit different, and that is because our common ratio for a decay curve is smaller than 1, or our b value is smaller than 1, but greater than 0. So this time it's going to start high and get smaller and then flatten out. Again, notice how it never crosses over my x-axis. And then, last and most importantly, the fourth thing you need to know about exponential functions is that exponential functions always grow faster than linear functions. So an exponential function that starts low and curves to grow high, that is the pattern of multiplying, will always grow faster than a linear function, which is a nice straight line. That's the overview of everything you need to know about exponential functions.